So today we are going to move ahead with idea of algorithm efficiency. So agenda of this video is I'll discuss best case, average case and worst case complexity. Then two examples of average case, best case and worst case will be discussed. Then I'll take some questions of finding complexity. So the very first topic is best case, average case and worst case complexity. So when we are writing the program, so worst case is a case in which we have to take maximum number of steps. For example, if we are using any loop, so if in the loop I have given a condition, so worst case means it has to execute all the iteration of the loop till the condition is true. Best case is in the first iteration itself that condition is true, then it will not have to execute the next iteration. Average case is average number of iterations it have to take. So the worst case complexity of any algorithm is a function defined by the maximum number of steps taken on an instance of size n. Means basically the less time is needed in best case, more time is needed in worst case. So best case is where minimum steps is taken, it means it will be executed fast. Average case means average number of steps are taken. So the example, suppose the first example is linear search on the list 1, 2, 3, 4, 5, 6, 7, 8, 9. So linear search is a program which I have already discussed in my list. So in this case, suppose I want to search for the item 1. So this will be the best case obviously. Suppose in the first iteration in linear search, what we do, we compare each and every element of the list with the element we want to search. So the best case will be, so in first iteration itself I get the number which I want to search, so it will return the index. The average case will be after few iterations I get the number, and worst case will be the last element to be found. So best case in this case will be 1, or even if we are using reverse loop, so 9 will be best case. The average case will be 5 and the worst case will be 9 if we are using positive loop, and if we are using negative means the reverse loop, in that case the worst will be 1, searching for 1. So the second example is the same list, we are using binary search. In binary search we divide the list we just find the middle element and compare the element to be searched. So in this case, suppose I want to search for 5. So this 5 is the first element to be found. So this will be best case. And suppose I want to search for 2. So it will again divide means if suppose I want to search for 2, it will search in this half of the list, then this half of the list. So this is average case. And worst case will be if we want to search 1 or if we want to search for 9, that will be the worst case. So the best case will be searching 1, that will be the first element. The average case will be 2 or 9 or 7 or 3, and the worst case will be 1 or even 9. So usually when we are attempting questions, so worst case complexity is asked or best case can be asked, but usually we work on worst case complexity. We avoid average case complexity because it is difficult to find average case complexity, because average case, suppose we are talking about the same example, average case can be finding 2, finding 3, finding 4, finding 6, finding 7, finding 8. So it will be difficult for us to find average case complexity. That is why we usually avoid. So you can see the graph. Best case means the less time is needed in best case complexity. You can see the time limit is less. Average case means more time is needed than best case. For same number of same input size, you can see that input size is same. Worst case means the maximum time is needed. So the first example, determine the complexity of program that searches for an element using linear search. So this is the program which I have already discussed in my previous video. So we will concentrate on complexity. The very first command to take input. Suppose it takes constant time C1, this second statement constant time C2, third statement constant time C3. Now it will come to loop. Loop 0 to length of L. Suppose this length is number of element. Let us consider it as n. N is the length of list. Now in this there are three statements. First, this suppose this takes constant time C4, then next constant time C5, then constant time C6. So these four elements, these three statements will take multiplied the time multiplied by n, that is the length of the list. And then for finally the last index last statement, it will take constant time C7. So in all the time will be C1 plus C2 plus C3 plus n into C4 plus C5 plus C6 and plus C7. So you can see, I have already told you about big O notation. The dominant term is n, that, and we will ignore the constant terms. So notation will be ON. So now the second example. Find the complexity for binary search. Now this is an important concept. So this is the program. I'm not going to concentrate on the program. Suppose the first it will take input from the user. Suppose the list is given here. So input from the user, second element, second statement constant time C2, third, fourth. Now when it is comparing, it will take constant time. Then see, now in this case, as the binary search divides the list by half, so its complexity is always log n to the base 2, because it depends, as I already told you, it depends what kind of input we are giving to search. If we are giving, suppose, the input which is the first element to be searched to be matched, then it is the best case, and it is worst case if it is the first element or the last element which is to be searched. So its complexity is always log n. This I will discuss how it will become log n. So in this case, suppose all the statements take constant time. So finally when we were calculating it, so whatever is there in the loop, so I'll show you whatever is there in the loop, this one, it will take the notation log n. You can see here, see, it will be multiplied by log n to the base 2. These are the statements. This is the constant time that will be needed. So next thing is, so finally because this is the dominant term, so the complexity will be O log n to the base 2. Now the next thing is how we are how complexity of binary search is log n to the base 2. See, when we are if suppose the iteration of binary search terminates after k iteration, we don't know how many times it has to iterate. It depends on the input. So at each iteration, the array is divided by half. Every time we are searching, we are dividing the list by half. So let's say the length of iteration is, any iteration is array, at any iteration is n. Suppose consider the length of array is n. Let us consider that the search terminates after 3 iterations. So how many times it will divide by 2? 3 times. So in first iteration, length of array is n. Second iteration, length of array will be n by 2, and third iteration, length of array will be n by 2 by 2. First iteration, sorry, it will be n by 2. And second iteration divided by 2, and third iteration n by 2 by 2, that is n upon 2 to the power 2. Suppose there are k iterations, suppose it will become k, so it will be 2 n upon 2 raised to the power k. So in this way, it will keep on dividing, converting the array into half, and the iterations will be calculated. And logically, after all the iterations, the length of array become 1. Length of array, how it will become 1? Because when it will search for the last element, suppose worst case, we are talking about the worst case. The element is the first element or the last element which we want to search. So obviously till we reach that particular element, the length will become n. So obviously we can say that n upon 2 raised to the power k becomes 1. We can just equate them, and then finally we will get the equation n is equal to 2 raised to the power k. We will get. Now we will apply log both the sides. Applying log, you can see here I have applied log. So log n to the base 2 is equal to, you can see, you must be knowing formula, x raised to the power m becomes m log to the base 2, 2 to the base 2. This we will get, and finally this will become 1. So k is equal to, finally number of iterations which we will need it is log n to the base 2. In this, that is why the complexity is log n to the base 2. The next example is determine the worst case complexity of this program. See, in this case again you can see here, this how many times this loop will execute? 0 to n, that is n times. So if it takes constant time c1 and it takes constant time c2, the overall time needed will be n into c1 plus c2. Similarly, suppose this will take number of iteration will be m. So suppose next statement takes constant time c3, then c4. So it will take, the time will be m into c3 plus c4. So ignoring the constant, so dominant term will be obviously n plus n. So the last program of this video is to find algorithmic efficiency, runtime efficiency of this. You can see this. So in this program there is a twist, that there we have used a function calc in which the efficiency is already given n square. So suppose the program will start from here. Suppose this will take iterate n times, that is depending upon the input. So I is equal to 1 take constant time c1, this comparison takes c2, and whatever is there inside this while loop, it will take the time n, because it will execute from I is equal to 1 to I is equal to n. So it will take n time. Then next statement, j is equal to 1, it will take constant time. This all constant time will be multiplied by n. Inside this there is one more while loop, and whatever is there in this while loop, it will be multiplied by again n, because it is compared by n. J is equal to 1, j is less than equal to 1, n. So whatever the value is of n is, depending on that, number of iterations will be executed. So basically this all will be multiplied, this n will be multiplied by this n. So finally we can see that this comparison time takes, suppose c4. After that this calc will take n square time. J is equal to j minus 1 will take, suppose c5, and then I is equal to I plus 1 c6. So finally we will get this one. See, in this you can see here c1 plus n into, because this is in this while loop, n into, then again from here c2 plus c3 comparison plus j is equal to 1 for c3, then n into, because from here the second while loop start, this while loop start, n into c4 plus n square, that is calc which is already given, and c5, that is j is equal to j plus 1. This closes. After this we have this while loop outside this, so c6 into n. Finally when we are going to open it, the dominant term will be O4. So finally our complexity will be O4. So my dear children, if you like this video, please like and subscribe. Don't forget to share. I hope you understood all the things. Please like and subscribe. Have a nice day.